Hi, my name is Vaibhav Govil. I'm a product manager in Cloud Spanner. Today I'm going to talk about how customers are future proofing their business for global scale and consistency with Cloud Spanner. So, as part of this talk, I'm going to cover three main areas. First and foremost, I'm going to introduce you to Cloud Spanner. Second, we are seeing a lot of momentum with Cloud Spanner for our customers, and I'm going to talk about what customers are using Cloud Spanner, which verticals, and what are their use cases. And last, I'm going to share some recent developments which we have done in Cloud Spanner, new features, new capabilities which are up and coming. So we'll talk about that. Okay. So to get to it, Cloud Spanner is a unique database. Basically, Cloud Spanner offers horizontal scalability with complete relational semantics. Horizontal scale is something which you would expect from non-relational databases, which are sharded and everything. Spanner does all that. In addition to offering you ACID transactions, complete SQL support, all the relational semantics which you expect from a relational database. To top it off, it's highly available, means we are talking about 5 nines of availability in a multi-regional configuration. It's fully managed. And this is something which Google built for itself. A number of our billion plus user products are sitting on top of Spanner. They use Spanner as the main database and something which we have been using for quite a long time. Now, how do we make it work? What are the key building blocks for Spanner? So there are three main elements to it. First and foremost, it's the Google's network. So Spanner is synchronously replicated behind the scenes. So a network plays a lot of role as part of what we offer to our customers in terms of latency, in terms of reliability, and having Google's network infrastructure backing Cloud Spanner is really important. And as you know, we and the Google's network infrastructure is redundant, highly available, and a Spanner being multi-regional and something which customers are using as a global database, network plays a big role. Second is true time. So the picture on the right of the screen, as you can see, they are atomic oscillators and GPS antennas. This is actually a picture for one of our servers in our data centers. And basically what it's showing you is we have atomic and GPS clocks in our data center. And what it offers is to our customers, this gives a global notion of time for Spanner to function on. So once there's a global notion of time for a distributed database, we can promise external strong consistency to our customers. And this is something which is extremely important. The ordering of transactions for financial services, for retail sector, and that is something which we are only able to offer because of true time. And last but not the least, we have a very optimized software stack with a custom Paxos implementation, automatic resharding based on lows and silos data, all the magic which makes Spanner work. So now, naturally, a question needs to be asked: Why Cloud Spanner? What is it so different in comparison to a relational database? First and foremost, as I already talked about earlier, it's scale and the scale insurance which customers get out of Spanner with high availability. So in terms of scale, there is literally no limit, and you can start small and seamlessly scale. That is very important for a number of use cases, which we'll talk about in the later part of the presentation. Second, multi-region with transparent synchronous replication. We are talking about a one-click experience in setting up a global instance across multiple continents. Strong external consistency, which I already discussed about. Pretty much as one box relational database experience you can get from a horizontally scalable Cloud Spanner database. There's no concept of planned maintenance windows, and that's why we are able to offer you such high availability. It's completely managed. You can also do completely online schema changes. You don't have to take a downtime for that. Uh, we have complete separation of storage and compute. This becomes extremely important for scalability. So you can seamlessly scale your workload because there's no coupling between storage and compute, and you can scale them independently. We launch managed backups. I'm going to talk a little bit more in detail about it, but they are consistent backups. We also offer cell level concurrency control, which is extremely important for a database like Spanner, which has use cases where customers are pushing in millions of QPS. And cell level concurrency control really helps. And again, we have databases internally which are petabyte plus size for a single database. So scale both on the QPS side as well as the storage side. So this is just a representation of some of the key feature highlights. Again, I'm not going to talk about each one of them, but these are the different categories where we continue to innovate and offer more features and capabilities to our customers. First and foremost, it's the enterprise and relational capabilities. So I talked about fine-grained concurrency control, manage backups. We have secondary indexes. On the programmability side, we continue to add more client drivers. We have 8, which are now in GA. We have complete DDL and DML support, including Bash DML. We have commit timestamps, which customers are using it for multiple use cases. Foreign keys, which was recently launched. Local emulator. We'll talk a lot about some of these capabilities later on as well. And then on the security side, uh, we launch VPC service control, access transparency. Uh, all the data by default is encrypted at rest. That's something which we offer. So a lot of capabilities which customers expect from an enterprise database from a security standpoint, and which not just Spanner but GCP overall is very good at. In terms of monitoring and introspection, we have a lot of capabilities which we continue to offer with more, uh, so we can provide more view into what your workload is doing. We have open census integration, CPU utilization graph, latency graphs, a number of those things. So moving on, now I talked about what is Cloud Spanner, what are some of the key capabilities which it offers. I think it's important to understand why customers are choosing Cloud Spanner, and for that, it's important to know what are some of the challenges which customers face today, and how Spanner kind of plays a role in terms of alleviating some of those challenges. So first and foremost, there are these business challenges for customers. For example, the first one is the capital expense which they have to take for some seasonal peak workloads. So let's say you are a retailer, you are planning for your couple of days of Black Friday, Cyber Monday sale, and to pay for all that fixed infrastructure for just those couple of days where you might experience 1,000% scaling is quite a bit. So that is something which goes on the books, and something they are concerned about. With Then the second thing is, all our customers and majority of them, they have global customer base of their own. They want to provide a great experience to their customers, so they have to invest in multi-region presence, which is again not cheap. And last but not the least is the operational expense, which is exaggerated by some of the seasonal scaling which comes with the workloads. So you have to plan for that operational maintenance and everything. So all this ties into the expense, but there is a human element to it as well because of operations and maintenance. On the technical side, uh, a number of customers we work with are very concerned about high availability. Means in today's day and age, if you are serving your traffic at the peak time, whether it's healthcare, it's enrollment season. For retail, it's some of those big days, and for financial services, any other times when a lot of payments are being made, high business continuity is needed. So how do you plan for that with appropriate DR capabilities? There should be absolutely no downtime. It should be able to scale seamlessly based on the workloads. Consistency is extremely important. For example, if you are doing a debit and a credit in a financial application, it's extremely important that the ordering of those transactions is maintained by the database as part of when it was done. And if you go back and take a look, that order should remain the same. And again, the global nature of the world which we live in, from a customer base perspective, everybody wants to serve their customers with low latency, and they need a consistent view of data globally. And last but not the least, the solution which they have needs to integrate with multiple systems, and whether a database provides those hooks. So, based on the critical capabilities which we discussed earlier, Spanner fits the bill in all of these and meets the requirements which customers come to us. So, as I mentioned, we are seeing a lot of momentum on Spanner across multiple verticals. Some of them are listed here. And if we think from the basically the differentiators of Spanner, which is like extreme scaling, high availability, strong consistency of data, and ease of use, uh, it's very easy to understand why all these use cases are coming to Spanner across gaming, financial services, healthcare, media, entertainment, technology. A lot of technology companies are coming and adopting Spanner, and retail. So let's just picking up on from the gaming side. If you are a game developer and you are making a game, you like to start small, and once the game makes it big, or you are the next Pokemon Go, then you don't have time to re-architect the app for that scale. So Spanner allows you to do exactly that you can start small with the right schema, and then you can seamlessly scale from hundreds to thousands to millions of queries per second and transactions, and for data size which can be similarly like in megabytes, GBs, or even petabytes. And a lot of customers are using it to store user profile, real-time gameplay data. A lot of those applications are there. Similarly, on financial services, extreme high availability, uh, external consistency, all those, and definitely ability to scale is extremely important. And that's why a number of banks are now switching to Spanner for their online banking and ledger use cases. Healthcare, we have a number of big healthcare customers who are implementing the complete EMR systems on Spanner, which is extremely exciting for us to see the healthcare space with all the compliance, HIPAA, PCI, we are in compliance. We offer that kind of compliance to our customers. So as long as it's implemented correctly. So healthcare and across a lot of these regulatory industries, we are seeing a lot of adoption, retail, technology. So as a next step, I'm not going to dive into each of these use cases, but just pick a couple of them and discuss them in detail. So first of all, this is financial services retail banking use case. This slide presents the complete solution architecture for it. So as you can see, basically the use case is there's this traditional retail bank which has migrated to Spanner. In this day and age, they have an omni-channel way for their customers to access the same financial data and transact with that through mobile, through web, through voice, and even third party. And this is basically just shown at the top of the slide. And then Spanner piece is right there in this red rectangle, which is the operational database side. And this is a very common architectural pattern which we have seen, where Spanner connects with GKE, and so it can seamlessly scale both from the client side as well as on the database side. So it's a very typical pattern. And then, as I was mentioning earlier, it's extremely important that the database can hook up with the legacy systems or other systems which are there. For example, the other core banking systems which are there, or payment gateways, as is shown at the bottom. And then as the data is getting updated in the OLTP database, which is Spanner, um, the data almost in near real time is getting populated in analytics and warehousing solutions as well. So the customer is able to do their OLAP queries and generate insights from that. That is within BigQuery and Cloud AI, data catalog, and everything. So that whole chain is set up using PubSub and Dataflow. And on the security and governance side, we offer all kinds of integration like cloud monitoring, DLP, and customers are able to benefit uh, with that across the board. So this is just one of those solution architectures where Spanner plays that operational database role and is able to seamlessly scale along with the rest of the architecture, which is extremely critical for our customers. Next, I'm not talking about the complete retail, omnichannel retail architecture for this customer, but just focusing on the Spanner piece. So in this case, the use case was the omnichannel retail customer is getting updated prices delivered to GCP through an external system, both as a streaming data pipeline as well as in batches, the data was being uploaded. And then Spanner was the database of record for all the SKUs with the updated prices. And then Spanner is serving those prices to all the applications which this omni-channel retailer is running. So as you can see from the solution architecture, that the prices are being uploaded in cloud storage, and then through load service running as part of Kubernetes is being uploaded into Cloud Spanner, and then Cloud Spanner is just serving all the requests from the pricing API standpoint. Again, in this case, Spanner is getting a lot of write load as well as read load, and depending on the traffic, it's able to scale up based on the needs of the application and the time of the day and everything. So again, very important. And in this case, they were using a multi-regional instance, so 5 nines of availability with global presence and everything. So extremely happy with the way it turned out, and and the customer is really very happy with the solution. So switching gears now, let's talk about what's new in Cloud Spanner. And just a reflection of the past a little bit. So we had a busy 2019. We delivered capabilities in in all areas. Basically, we have categorized in these three major areas: enterprise, capabilities, developer productivity, and SQL. So on the enterprise side, I already talked about VPC, access transparency, which is extremely critical for some of our regulatory industry users, where when even Google SRE, when they touched your data for any reason, that kind of an action has to be logged. So that is access transparency. Spanner supports access transparency, and we updated our SLA in September 2019. Basically, now all your Cloud Spanner instances, even with a single node, are covered under the same production SLA. So this way, even for smaller workloads, you are protected by the same SLA which we offer. Before September 2019, we used to require minimum 3 nodes in an instance. And the reason we were able to update our SLA is because Spanner behind the scenes is replicated. So even in case of a regional instance, there are 3 replicas. And we are able to offer you that high availability with a single node. And multi-region, it's multiple replicas like 5, 7, and 9 replica configurations is something which we offer today. On the developer productivity side, we continue to invest in ORMs. We have launched a new initiative and something which is getting a lot of momentum called as Cloud Spanner Ecosystem. The website is actually cloudspannerecosystem.dev or dev. And because, as you noticed, we have a lot of momentum with Spanner. A number of our customers are contributing tools in the ecosystem for other Spanner users. And we have a lot of partners contributing tools and Googlers as well. So we created this ecosystem as a single place where they can make their contributions for the benefit of the overall community. And we are seeing a lot of traction. Please check it out. There are a number of tools which are available for our users. And last but not the least, on the SQL side, we continue to innovate for the query optimizer. We launched cost-based index selection as part of the query optimizer optimization. We have batch DML support. We launched with clause. Again, trying to offer all the capabilities which you expect from database from the SQL side. We had a fairly busy 2020 so far. Again, in all those three areas, we continue to make improvements and launch new capabilities. Uh, and like manage backup restore, I'm not going to spend too much time here. I'll go into details later. We continue to expand on our multi-regional configuration options. Uh, we originally had four multi-regional instance configurations. We recently launched two new multi-regional configurations, one an Asia only multi-region and another one in Europe. And then we recently launched a change watcher solution, which is not a native capability, but a solution which is built on top of Spanner, leveraging the commit timestamp feature where customers can watch out for changes which are happening within their database. And on the developer productivity side, we emulator is something. This is an offline emulator. I'm going to talk more in details later. But C++ client library, transaction statistics, and Harbor Bridge, which is another tool which was recently contributed in Cloud Spanner ecosystem. It is to aid in migration. It actually the capability it provides is if a customer has a PostgreSQL schema and they use HarborBridge, the tool can recommend an equivalent spanner schema with it. So originally we launched it for PostgreSQL support, and for MySQL we have launched it in beta right now. And on SQL side, query optimizer versioning, I'll talk more in details on that later, and foreign keys. So I'm not going to go into details of each one of these capabilities, but I'll pick one from each of these areas and tell you a little bit more about them. So first and foremost is managed backups, which we launched with general availability in April. So this is on-demand managed backups. This is primarily to offer protection to our customers against operator application errors, which can cause logical data corruption. So what we offer is consistent backup for regional and multi-regional instances. And what we are optimizing for is extremely fast restores or first time to first byte access. So because if you run into an issue, you would like to get back online with your application as soon as possible, and we recognize that. So even for a backups which is terabytes of in size, you can expect to get first byte access as part of your restore process within minutes. So that is something which we have really optimized for. You can restore from your backup within the same instance configuration, or basically within the same instance or another instance within the same instance configuration. And the maximum retention time for backups is 1 year. And from a security perspective, our IAM access permissions are separate for backups. So uh, customers have the flexibility to create a separate role just to manage the backups and do the restores. So that is there. And again, the feature is available through API console G-Cloud. Local emulator. So this is something which we announced in beta in March. I'm happy to announce the general availability of local emulator as part of this talk. So this is now generally available. We have uh, implemented a lot more capabilities uh, as part of this general available launch for local emulator. It is an offline open source local emulator. The code is open. You can take a look. It's in a GitHub repository. It offers complete REST and gRPC API support, and it offers SQL, basically DML and DDL support. Most importantly, it has complete support for information schema as well. Now, all client libraries are supported for working with emulator. And this really, we have got great feedback from a number of our customers, and it has really helped them from a productivity, developer productivity perspective, because now they can do a very quick correctness testing for their application in an offline environment. And last but not the least, Cloud Spanner offered query optimizer versioning capability to our customers. And this is a GA feature. So basically, what does it mean? Now users have the flexibility to run their queries with a specific version of query optimizer. There's a range of choices which we offer. You can pin your complete database on a query optimizer version, or you can decide to pin just your application on a specific query optimizer version with the default query optimizer for the database as being something different. So you can override the default on the database. And finally, you can use a specific query optimizer version as a query hint as well. And you can test your query with a specific query optimizer version. So there's a range of choices and flexibility which we offer as part of this feature. And customers can decide to pin their application or the whole database and get that same predictable performance from Spanner. So that concludes my presentation. But as next steps, we have a couple of very interesting talks planned for Spanner. So first, we have a talk which one of our customers is going to give about switching from DynamoDB to Cloud Bigtable and Spanner. Please tune into that. It was a fairly big undertaking in terms of migration from Dynamo. We are talking terabytes of data and uh, a lot of throughput in that application, which they migrated from Dynamo onto Spanner and Bigtable. And then there's another talk which one of our gaming specialists is giving about how customers can modernize their gaming applications with Spanner, again, to benefit from the scale and consistency which Spanner offers. There's also a showcase demo which has been planned, and there's a quick lab. We welcome you to try it out and, and learn more about Spanner through that. With that, thanks a lot. Thanks for your time and attention. I really appreciate it. And thanks for using Spanner. And please reach out to us if you have any questions. Thank you.